Good evening, students. So, today we are discussing problems in SHM and wave motion. Okay. So, this is first question. A particle is performing SHM with time period capital T. At an instant, its speed is 60% of its maximum value and is increasing. After an interval delta T, its speed becomes 80% of its maximum value and is decreasing. The smallest value of delta T in terms of capital T will be. Okay. Now, this is the question. Now, we can represent the linear SHM on a circle. Okay. Linear SHM on a circle whose radius is amplitude. Okay. So, if a particle is executing SHM, this will be mean position and this is right extreme position, this is left extreme position. If I take, I can represent the position of the particle and velocity of the particle both on this circle. Okay. When particle is at mean position, then that point corresponds to circle here, this point. Okay. When it is at mean position, when it is at right extreme position, that point corresponds to this point, and when it is crossing mean position towards left, that point corresponds to this point, and when it is at left extreme position, this is the point on the circle. Okay. And if particle is somewhere here and going towards right, means its position is positive, velocity is also positive, then we represent in first quadrant the radius vector, first quadrant. And if this angle is theta, what is radius will take is amplitude. Okay. Then what is this position x is a sin theta, and if it is velocity, it is v naught cos theta. Position you can find by a sin theta. Okay. And velocity is a cos v naught cos theta, where v naught is maximum velocity. Similarly, if particle is somewhere here towards right of mean position and going towards left, then the radius vector will be in second quadrant. Then we can measure this angle or this angle also. If I take, it does not matter. Then what is position? A sin theta, but negative, and velocity v naught cos theta once again. Okay. And if particle is somewhere here going towards left, then the radius vector will represent in third quadrant. Then its position is given by a sin theta and velocity is given by v naught cos theta once again. Okay. Actually, phase constant means this angle will take, or this angle if you measure like this will represent with a minus sign. If you measure in anti-clockwise direction, we represent with plus sign. And if it is towards left of mean position and going towards right, then position is negative but velocity is positive, then we represent in fourth quadrant. Then once again, what is position? A sin theta and velocity v naught cos theta. Okay. That's what I'll get. But in both the cases, position is negative. In this both cases, position is positive. And now, if I see like that, now in this case, the particle is executing SHM. At an instant, its speed is 60% of maximum speed, means 3 v naught by 5. 3 v naught by 5 and speed is increasing. So, when a particle is moving towards mean position, its speed will increase. If it is going away from mean position, its speed will decrease. Means if I assume that particle is somewhere here now, that instant, speed will be in this direction, and that is 3 v naught by 5. 3 v naught by 5. So, where should we represent this radius vector now? Particle is towards right of mean position and going towards left. So, it should be in second quadrant. And this is v naught cos theta. V naught cos theta means cos theta is 3 by 5. 3 by 5. Okay. Means 53 degrees. So this is the position of radius vector, and we can assume that radius vector is rotating with constant angular velocity omega, where omega is angular frequency of SHM. This is in radian per second, and here omega is per second, that is angular frequency. Okay. Now in the second position, its speed becomes 80% of its maximum value, and it is decreasing, means it is going away from mean position, and it should be somewhere here. 80% means it will be 4v naught by 5, going away from mean position. Means where should you represent here? This, on this circle, the radius vector, this position, it is towards left of mean position and going towards left, means what? Third quadrant, and v naught cos theta is 4v naught by 5, means it is 37 degrees. So this is the position. What is the time to rotate from here to here? Is 90 degrees. Okay. So theta equal to omega t, you can write that. Theta equal to omega t, where omega is angular velocity with which this radius vector is rotating, which is nothing but in magnitude the angular frequency of SH. Okay. What is theta? Pi by 2. So pi by 2 equal to omega t. What is t? Pi by 2 omega I will get. Okay. Pi by 2 omega. Actually it is 90 degrees, means 1/4 of time period. It is 360 degrees, it is time period. Okay. So 90 degrees is 1/4 of time period, directly you can write, that is t by 4. Okay, followed. So next question. Next, this is the question. Okay. Two particles A and B are performing SHM along same straight line with same amplitude A and same angular frequency omega. At t equal to 0, A is at left extreme and B is at a distance a by 2 from mean position to the right of mean position and moving towards mean position. Then their phase difference is 5 pi by 3. Their phase difference is 2 pi by 3. Time after which they cross each other is 2 pi by 3 omega. Time after which they cross each other is pi by 3 omega. Okay. Once again we use that circle, okay, to represent that SHM. Now where is the particle initially? If this is mean position and amplitude is A, one particle is here to left extreme position. Okay. Left extreme position means this is the point. Okay. So this radius vector represent this position. Okay. Right extreme position means this position. Left extreme position means this position. Okay. And other particle is at a distance a by 2 towards right of mean position. From mean position to the right of mean position and moving towards mean position, means it is here at a distance a by 2, moving towards mean position, means in this direction. Means what? Position is positive, velocity is negative. So where do you represent? In second quadrant. Second quadrant. Second quadrant, and what is theta? A sin theta should be a by 2. Means theta is 30 degrees or pi by 6. So this is pi by 6. But actually what is phase of this means this angle you should take at t equal to 0. Okay. If I take at t equal to 0, this is called phase constant. So what is phase of first particle? This is first particle, that is 3 pi by 2 or minus pi by 2. If you measure like this, anti-clockwise direction with x-axis, then positive you should take. If you measure in clockwise direction with x-axis, you should take negative. So if you measure it like this, it is 3 pi by 2. If you measure it like this, it is pi by 2. So for first particle, what is phase constant? Minus pi by 2. And second particle, if you measure like this, it is pi minus pi by 6, that is 5 pi by 6. Okay. So what is phase difference between those two? You have to subtract both of them. Okay. Or this angle you can directly take. Okay. So subtract, what do you get? 5 pi by 6 plus pi by 2. Means 8 pi by 6 you get. 8 pi by 6 means 4 pi by 3. 4 pi by 3 or 2 pi minus 4 pi by 3. Anything is correct. Okay. Add these two, what do you get? into 3 by 3, that is 3 pi by 6 and 5 pi by 6. You have to subtract actually. Subtract means it gets added. So 5 pi by 6 plus 3 pi by 6 means 8 pi by 6, that is 4 pi by 3. 8 pi by 6 means 4 pi by 3 or 2 pi minus 4 pi by 3, like that also you can. Okay. If you measure like this, you will get phase difference in anti-clockwise direction. If you measure it like this, clockwise direction, you will get negative. Okay. So if it is like this, pi by 6 plus pi by 2. Pi by 6 plus pi by 2 means 3 pi by 6 plus pi by 6. 4 pi by 6 means 2 pi by 3. Okay. So it is 2 pi by 3 or minus 4 pi by 3, whatever it is. Both of them are correct. Okay. So this is the answer. Next, time after which they cross each other. Now when they cross each other, because it is starting from left extreme position and this is starting from midpoint, they will meet somewhere here. Meeting means what? Both of them should come to same position, but their phase need not be same. But this particle will be crossing this point towards left and this particle will be crossing this point towards right. Okay. So for the first particle, where is this radius vector? You should represent velocity towards right, but position is negative. So it will be in fourth quadrant. So it will come somewhere here. Okay. So represent it here. If this angle is theta. Okay. But both of them have same position here because they are meeting. Both of them have same position. So both the radius vector should make same angle with x-axis or negative x-axis if it is in second and third quadrants. If it is first and fourth quadrants, we will measure with positive x-axis. And at the same time, the second particle will come here, but it is moving towards left. Means its x is negative, velocity is negative. Means you should represent in third quadrant. But because position is same, theta should be same. So this is theta. Means by the time it has rotated from here to here, this has rotated from here to here. Okay. Because omega is same, theta should be same. In a time t, this is rotated like this also is rotated like this. And omega is same for both of them. So theta should be same, theta equal to omega t. So how much it has rotated? Pi by 6 plus theta. That is equal to how much this has rotated? Pi by 2 minus theta. Okay. So 2 theta equal to pi by 2 minus pi by 6. Okay. That is 3 pi by 6 minus pi by 6. Okay. 2 pi by 6. That is pi by 3 LZ, I think. So theta is pi by 6. Theta is pi by 6. Means how much this has rotated? Pi by 6 plus pi by 6. That is pi by 3. Pi by 3 means what? 60 degrees. Means if it is 360 degrees, it is capital T. 60 degrees, 1/6. So capital T by 6 will get. Okay. Okay, in terms of omega only they have given, you can find. Capital T by 6. But what is capital T? 2 pi by omega. So 2 pi by 6 omega or pi by 3 omega. Okay, so that is the question. So this is second question. So this is third question. Figure shows a smooth horizontal table in XY plane between two identical fixed walls. Two identical springs are connected to the small ball. The length of the spring in free state is L, and initially they also have given L, means both the springs are in their natural length. The ball is shifted slightly from equilibrium position in two different ways, once along the OX and second along Y axis, and it begins to perform vibrations. The time period for these motions is Tx and Ty respectively, then both SHM, and what is time period, that's what they are asking. Okay. So first of all, if I see displacement is in this direction. Now if a particle is executing SHM, what we have to show? We have to show the net force acting on that particle is proportional to displacement from mean position and directed towards mean position. That's what you have to show. Then only it is SHM. Otherwise, if net force is directed towards mean position but not proportional to displacement from mean position, such a force is called restoring force. Okay. Whether it is proportional to displacement from mean position are not proportional to displacement from mean position. If it is always directed towards mean position, such a force is called restoring force, and that mean position is called stable equilibrium position. Then it will describe oscillatory motion, but oscillations may not be SHM unless the restoring force is proportional to displacement from mean position. So if I, in this case, if I displace in this direction and release it, so if I displace it in this direction by very small displacement x is very small when compared to L, okay. Then what is net force acting on this? This spring is compressed by x, this spring is elongated by x. What is net force? By this spring, kx towards left, by this spring also kx towards left. Then what is resultant force? Is 2kx towards left, means towards mean position, and proportional to displacement from mean position. So it is simple harmonic motion, okay. Then what is angular frequency of oscillation? Is root of coefficient of x by m. Root of coefficient of x by m, okay. Root of 2k by m. So that is angular frequency of oscillation. What is time period? 2 pi root m by 2k in the first case. So this is correct only. This is correct, okay. And motion along x-axis is simple harmonic. This is also correct. Is it given? It is very small displacement, shifted slightly, okay. It is not slightly, also it will be SHM anyhow, because it is proportional to x anyhow, okay. And now if it is displaced like this, what happens? Now if I displace it by y, then this spring will be somewhat like this and this spring will be somewhat like this. These are the positions of the two springs. Then what is elongation in this spring? If it is delta L, then this spring force is in this direction, that is k delta L, and this is in this direction, that is also k delta L. And if this angle is theta, this angle is theta, then what is net force towards mean position? Is 2k delta L cos theta. 2k delta L cos theta. So that is restoring force now. But what is delta L? Is increase in spring length, okay. So what is length of the spring now? If this is L, this is y, this is root of L square plus y square. So delta L is root of L square plus y square minus L. So it is 2k into root of L square plus y square minus L into cos theta. What is cos theta? Is y by this length, that is root of L square plus y square, okay. Y by root of L square plus y square is almost 1, okay. We'll see. Y by root of L square plus y square, and L is much greater than y. Means I ignore y square when compared to L square. So it is y by L, you can write directly, okay. But this also you can do by binomial theorem, because L is much greater than y, okay. So if I take L square common, what do you get first term? 2k L outside you'll get into 1 plus y square by L square whole to the power of half, then minus 1, okay. We have taken L square common, okay. So L outside, so minus 1 into, that is y by L, okay. That's what it is. Now this can be written as, because y square by L square is very small when compared to 1, this can be written as 1 plus x whole to the power of n can be written as 1 plus nx. So this is nothing but 1 plus y square by 2L square minus 1. So 1 cancels, you get y square by 2L square. So this is nothing but 2kL into y cube by 2L cube. So this cancels, you will get L square here, okay. 2 also cancels. So this is ky cube by L square L. That's what it is. So net force is restoring only, because it is towards mean position, opposite to direction of displacement from mean position. But it is not proportional to y, displacement from mean position. It is proportional to y cube. So it oscillates, but not, oscillations are not simple harmonic, okay. Oscillations are not simple harmonic. So this B is wrong. This is also wrong, D, okay. Okay, followed. Now next is this question. In the given figure, time period of small oscillations is small m is equal to 1 kg, k equal to 5 Newton. So both blocks same masses and all pulleys smooth and massless will take. Then it is only translatory motion, no rotatory motion. So this is oscillating, okay. We can do by energy method, okay. So what is energy method of SHM? It is ax square plus bx dot square is constant. This is potential energy term, this is kinetic energy term, that is dx by dt, that is velocity. This is total energy of oscillation, total energy of oscillation C, okay. Potential energy plus kinetic energy is equal to total energy. Then what is angular frequency of oscillation? Is root of a by b, root of coefficient of x square by coefficient of x dot square, okay. If I write like that, for example, if it displaces by x, this pulley moves by x, means this block should come down by 2x. So they are initially in mean position, but if it comes down by x, this block comes down by 2x. So from mean position, when it is at a distance x from mean position, let us say its velocity is v, then its velocity at that instant should be 2v, okay. So assume it is displaced by x from mean position, okay. Then it has come down by 2x in that time. Then at that instant, it has moved by x, okay. Its velocity is v, let us, then its velocity at that instant should be 2v. Its velocity should be 2v, okay. Then what is spring energy gain is half k x square. How much it has come down, so much is increase in elongation. So what do you get? Half k x square is LHS. Already what is energy, potential energy is there in mean position. That is not included in energy of oscillation, okay. Only increase in energy of oscillation I want here. Ax square means this is potential energy term, this is kinetic energy term, okay. And energy of oscillation is not total potential energy plus kinetic energy. It is only increase in potential energy when particle is displaced from mean position. There can be some potential energy at mean position, that you should not include in energy of oscillation. So what is energy of oscillation? When particle is displaced from mean position to some other position, energy of oscillation is increase in potential energy plus kinetic energy, or it is kinetic energy at mean position. That's it is kinetic energy at mean position. So what is increase in potential energy is half k x square. Gravitational potential energy will change and spring potential energy also will change. Those will cancel, okay. Half k x square. And increase in kinetic energy. What is kinetic energy of this block? Half mv square, and this block half into m into 2v whole square. So 4 into half mv square, and this is half mv square, that is 5 mv square by 2, that is constant. So what is angular frequency of oscillation? Root of a by b. So root of k by 2 by 5m by 2. So that is root of k by 5m. Root of k by 5m. What is k given? 5. M is 1. So k 5 m 1. So root 1, that is 1 I'll get. So what is angular frequency of oscillation? Is 1 per second. Time period is 2 pi by omega. So 2 pi I'll get. What is time period? 2 pi seconds, okay. What happens if they are rotating also? We'll see anyhow. Now this is next question. A particle of mass m can move in a force field. The potential energy U varies on location of the particle according to the following equation. U equal to minus k into x minus a whole square into x minus b whole square. Here k, a and b are positive constants. What can you conclude about small amplitude oscillations of the particle? It can oscillate about a specific location with angular frequency b minus a into root 2k by m. It can oscillate about two separate locations with angular frequency so much. It can oscillate about a specific location with angular frequency so much. It can oscillate about two separate locations with angular frequency. Now when they give potential energy in terms of x, all maximum potential energy positions, they are unstable equilibrium positions. Maximum potential energy positions are unstable equilibrium positions. Then it do not describe oscillatory motion about those positions. All minimum potential energy positions where potential energy will decrease until that moment and later on increases, they are stable equilibrium positions, and about stable equilibrium positions the particle describe oscillatory motion. Then how do you find whether it oscillates or not? Any potential energy function is given. So potential energy function is given, then you have to find force. What is force? Minus du by dx. Let us say this is some g of x. This is some g of x, force function. Then how to check about which positions it will oscillate? You have to first of all equate force to 0. You have to find mean positions. Means equate force to 0 and find values of x at which force is 0. They are mean positions. Okay. Then all minimum potential energy positions, means where du by dx is 0, they are equilibrium positions. There d square u by dx square is greater than 0, double derivative, that is minimum potential energy position. So about those positions it describes oscillatory motion. So where du by dx is 0, there if d square u by dx square is less than 0, that is maximum potential energy position. Where it do not describe oscillatory motion, it is unstable equilibrium position. Okay. But okay, you can check all those things, but directly if I see after finding force in terms of x for small amplitude oscillations, whether it oscillates or not, how do you check directly without doing d square u by dx square and all those things? Simply differentiate force once again. If I differentiate force, what do you get? df is equal to g dash of x dx. Then substitute here the values of x in equilibrium position. In equilibrium position, and if this coefficient of dx is negative, that is stable equilibrium position. If this coefficient of dx is positive, it is unstable equilibrium position. If this coefficient of dx is 0, it is neutral equilibrium position. So it will oscillate only about stable equilibrium position where coefficient of dx will be negative. So if you get coefficient of dx negative, then take that coefficient of dx at that point, which will be a constant. Then what is angular frequency? Root of coefficient of dx by n. That's how we can find. So you need not check whether it is stable or unstable by double differentiating. Simply find force in terms of x, find equilibrium positions by equating force to 0, then differentiate force once again. Then you will get some function of x, or you may get a constant also directly. If this is a function of x square, force is a linear function of x, then if I differentiate force, you will get directly constant. But sometimes you may get a variable also, this one in terms of x. Then substitute that equilibrium position values. If coefficient of dx is negative, that is stable equilibrium position. If it is positive, unstable equilibrium position. If it is 0, neutral equilibrium position. Then angular frequency of oscillation you can find by considering coefficient of dx as k. So root k by m. And time period also you can find. Now in this case also they have given u in terms of minus k. So all minimum potential energy positions are stable equilibrium positions. Okay. So if I plot the graph u versus x, what type of graph you will get? Okay. At x equal to a, potential energy is 0. So if I take x equal to a, potential energy is 0. X equal to b also, potential energy is 0. So the graph should touch x axis at x equal to a and x equal to b. But if I see such a function, what is du by dx is force with minus sign. But anyhow, if I differentiate this, one term will be 2 into x minus a into x minus b whole square if I use product rule. Other term will be 2 into x minus b into x minus a whole square. Means at x equal to a and x equal to b, force is also 0 because du by dx is 0. Means they are equilibrium positions. X equal to a and x equal to b, okay, are equilibrium position. But x minus a whole square and x minus b whole square are always positive, whatever is the value of x. But there is a negative sign outside, so potential energy is always negative, always negative. So at x equal to a, potential energy is 0, force is also 0, okay, and in between two zeros the function is negative. Function is negative means it should decrease and increase. Between two zeros, if that function is negative, it should decrease and increase. Okay. So here these two should be maximum. In between it should reach minimum value. So what type of graph will get? Like this will get. Then here it decreases. Then once again like this. Then these two are maximum values means what? Before that it should decrease potential energy as x decreases. After that also as x increases, potential energy should decrease. That's what it is. So in between we will get a minimum potential energy position, which is stable equilibrium position. So about this it describes oscillatory motion. About this point it will describe oscillatory motion. Okay. So there is only one point about which it describes oscillatory motion. There are not 2 points. 2 points are unstable equilibrium positions, x equal to a and x equal to b. Okay. Now how to find this point? You can always find. What is the third point where force is 0? You can find. What is force? Minus du by dx. So what is force? K into, if I differentiate first term, we will get 2 into x minus a into x minus b whole square, and second term, okay, if I differentiate with a minus sign, what do you get? K into, first term if I differentiate, I will get 2 into x minus a into x minus b whole square, okay, plus second term if I differentiate, 2 into x minus b into x minus a whole square. Okay. What are equilibrium positions? Means net force is 0. So equate this to 0 means if I take x minus a into x minus b common, what is first term? X minus b. What is second term? X minus a should be 0. Means what is x? A plus b by 2. So x is equal to a plus b by 2. So this is stable equilibrium position. Exactly midpoint of those two. Okay. And how do you find angular frequency of oscillation about stable equilibrium position? You have to differentiate force once again and put that value x equal to a plus b by 2. Okay. You have to differentiate this once again and put this value of x there. Then coefficient of dx you should take, which is k, root of k by m. Okay. So what is this term we will get? If I take x minus a into x minus b common into 2, first term we will get x minus b here, x minus a. So 2x minus of a plus b will get. Okay. 2x minus of a plus b. So what do you get? F is equal to 2k into x minus a into x minus b into 2x minus of a plus b. This is force function, and x is equal to a plus b by 2 is stable equilibrium position. Then how do you find angular frequency of small amplitude oscillations about stable equilibrium position? You have to differentiate force. If I differentiate force, what do you get? This you have to do. Okay. Then some function into dx will get. In place of that function, you have to put that value. Then coefficient of dx will get negative anyhow. Then positive value of that you should take, and root of k by m will be angular frequency of oscillation. I think you can simplify differentiation and all those things. Okay. You can, if you want, you can multiply these two and differentiate also. If I multiply these two, what do you get? The square minus of a plus b into x plus ab. Okay. So if I differentiate, what do you get? 2k into, if I differentiate first term, you will get 2x minus of a plus b, second term 0, into second function, that is 2x minus of a plus b, plus derivative of second function is 2 into first function, that is x square minus of a plus b into x plus ab into dx, whole multiplied by dx. Okay. That's what it is. Now here you should put x equal to a plus b by 2, but be after simplification. Okay. This is nothing but 2x minus of a plus b whole square. Okay. That is 4x square you will get a plus b whole square you'll get, so minus 4x into a plus b. Okay. I think you can simplify. The next question is the question. A simple pendulum initially oscillating simple harmonically with angular amplitude alpha and period t naught is symmetrically confined between two rigid fixed planes A and B, making angle beta is less than alpha. Beta is less than alpha. What is angular amplitude is alpha with each other as shown in the figure. If collisions at both the walls are elastic, period is T naught into 1 minus beta by alpha. If collisions are perfectly inelastic, period is T naught. If collision is at one wall is elastic and at other wall is perfectly inelastic, the period is T naught. If collision at one wall is elastic and at other wall is perfectly inelastic, the period is less than T naught. Okay. So what is amplitude of oscillation? This is one wall here and this is another wall here, and this angle is beta and this angle is also beta. Amplitude of oscillation is alpha, which is greater than beta. Greater than beta means once you project it, it goes somewhat like this and oscillates. Okay. But alpha and beta should be very small angles anyhow, less than 5 degrees, around 5 degrees. Okay. So here it goes like this and collides here. If there is no wall, it could have gone up to alpha, then comes back like this. Then what is time period of oscillation? If total time period is T naught, what is T naught? Is 2 pi root L by G. T naught is 2 pi root L by G. Okay. But it goes and collides elastically, means no energy loss, it rebounds with same speed and comes here and collides elastically and goes like this. Then what is time taken from here to here? Is same as time taken from here to here, and same as time taken from here to here, and time taken from here to here. So how do you find time taken? To displace by beta from mean position. So then we use angular SHM equation. What is angular SHM? Is theta equal to theta naught sine omega t plus phi. Once it starts from mean position and going towards right, phi is 0. So theta equal to theta naught sine omega t, will write. Theta naught means amplitude, that is alpha, sine omega t. What is time taken to go from here to here? Means time taken for angular displacement to become beta. So put theta equal to beta, then you will get time. So what is that time? 1 by omega sine inverse theta by beta by alpha. Beta by alpha. Okay. But what is omega? 2 pi by t. Okay. Omega is 2 pi by t naught. So this is the time I will get from here to here. The same time it will take from here to here, here to here, and here to here also. So now what is time period of oscillation? Is 4 times this. What is time period of oscillation now? Is capital T, let us say. That is 4 times this. Okay. So 4 by omega into sine inverse beta by alpha, okay, which cannot be this anyhow. Okay. So that is wrong, first one, first choice. Next, if collisions at both the walls are perfectly inelastic, period is T naught. If it is perfectly inelastic, what happens? If I assume it collides normally, okay, then it rebounds, it just stops immediately after collision, perfectly inelastic collision. It stops if it collides normally, okay. It stops immediately after collision. After stopping, what happens? It starts coming, unless it sticks to it, it comes back. So it comes back and once again it should stop here only exactly, because both angles are same, then oscillates. And it is free oscillation anyhow, so it won't collide with neither of the two walls later on. Okay. So it is free oscillation, but with what amplitude now? Beta. Angular amplitude is beta, but angular amplitude is decreased when compared to earlier angular amplitude. Okay. But that particle has not gone to that anyhow, these walls are preventing. But still, time period do not depend on angular amplitude. It is 2 pi root L by G. So same time period you will get. So if it is perfectly in inelastic collision with any one of the walls, it is time period is T naught after that collision onwards. Okay. So that is correct. Choice B. Next, if collision is at one of the walls is elastic and other wall is perfect inelastic, the period is T naught. That is also correct. One wall is elastic, then it rebounds with same speed, but other wall perfect inelastic, then it stops there. Then later it cannot collide that anyhow. It just stops at that wall and once again oscillates with an amplitude of angular amplitude of beta. So once again time period is T naught. That is also correct. So C is also correct. If collision at one wall is elastic and at other wall is perfectly inelastic, the period is less than T naught. That is wrong anyhow. C is correct. Okay. The next question. Two identical simple pendulums, each of length L, are suspended from the ceiling. Their bobs, each of mass small m, are connected by a very light relaxed elastic cord. Elastic cord means string, okay, a force constant K as shown in the figure. If the bobs are symmetrically pulled apart slightly and released, what is the period of ensuing oscillations? Now, if it is a simple pendulum, what is the restoring force if I slightly displace it from mean position? Actually, you can take it as linear SHM also, it does not matter. It is a very small curve which can be treated as straight line. Then what is restoring force? It will be G sin theta. G sin theta, that is the restoring force. Okay. It is actually T. This angle is theta, let us say. This angle is 90 minus theta. Then what is net force? Is T sin theta. T sin theta. Tension in this sin theta. But T cos theta is mg. But cos theta, theta is very small, cos theta is almost 1. So T cos theta is mg means what? T is mg. And what is restoring force? T sin theta means mg sin theta. So restoring force is mg sin theta. But what is sin theta? X by L. X by L. So what is restoring force? G x by L. G x by L. So in SHM, what is restoring force? Is mg x by L. Okay. Acceleration towards mean position is g x by L and restoring force is mg x by L. Okay. Now once you displace these two slightly by x or any one we will take. Let us say this is displaced by x, this is also displaced by x. Then middle string is expanded by 2x. Then what is net restoring force acting on this ball or this ball if I take in this direction 2kx I will get. That is because of this string, and restoring force because of tension is T sin theta, which is nothing but mg x by L, which is mg x by L. What is net restoring force? Is x into mg by L plus 2k I will get. That is the restoring force. Okay. That is until it comes here or this comes here. Then afterwards, once they come nearer for this part of the oscillation, this string become loose. Means this string do not apply any force. So it do not play any part during this half of the motion. So this half of the motion, what is time period? Is like just simple pendulum, that is pi root L by G L. Half the time goes to extreme position and again come back to mean position. What is time? Total oscillation is 2 pi root L by G, but half oscillation is pi root L by G. So from here to here and here to here, it is pi root L by G. And from here to here and here to here, it is half of this time period. Half of this time period. So what is total time period of oscillation? Is pi root L by G plus what is this omega here? Is root of coefficient of x by m, that is root of g by L plus 2k by m. And what is time period? 2 pi by omega, 2 pi by omega, but this is half of this time, that is pi by omega, pi by omega. Okay. So pi if I take common, it is root L by G plus 1 by omega. Okay. 1 by omega. 1 by omega is nothing but root of g by L plus 2k by m whole to the power of minus half. Okay. Plus root g by L. Okay. So you can choose the choice. This is a question from waves. Okay. A block of mass capital M hangs vertically at the bottom end of a uniform rope of constant mass per unit length. That is, lambda is constant or mu. Okay. The top end of the rope is attached to a fixed rigid support at O. A transverse wave pulse of wavelength lambda naught is produced at point O on the rope. The pulse takes a time TOA to reach point A. If the wave pulse of the wavelength is lambda naught is produced at point A, pulse 2, without disturbing the position of capital M, it takes TA naught to reach point O. Which of the following option is correct? A block M is hanging and it has a constant mass per unit length they have mentioned, but this mass, if it is very small when compared to capital M, then with what velocity this pulse will travel will be constant. And what is velocity? Root T by mu. Root T by mu. Mu is same everywhere, okay. And T is capital Mg. If this mass is very small when compared to capital M, what is T? Capital Mg. Then tension is also constant. Then velocity of this pulse and this pulse are same. If everywhere tension is same, okay. Then what happens? They pass through midpoint, that is correct, okay. Because velocities are same, this is going up, this is coming down, they should pass through midpoint, okay. After what time they pass, you can find. And how much time it will take to go from here to here is L by V. And this also should take same time, L by V, to come to the bottom, okay. So TOA, TAO equal to TOA, that is correct. Next B, the wavelength of pulse 1 becomes longer when it reaches point A. Now what happens to wavelength? V equal to n lambda. Okay, frequency do not change as it is progressing wave, but velocity changes, lambda changes. If velocity decreases, wavelength decreases. If velocity increases, wavelength decreases, okay. So in this case velocity is not changing, therefore wavelength also do not change. I am assuming this is mass is very small when compared to this, okay. So velocity, wavelength do not change, okay. But what happens if this mass is comparable to this also, we will see. The velocity of any pulse along the rope is independent of its frequency and wavelength. That is correct anyhow, root of T by mu. So velocity is independent of wavelength and frequency. The velocities of the two pulses, pulse 1 and pulse 2, are the same at midpoint of the rope. That is also correct. At midpoint, because tension is same, their velocities has to be same, okay. But what happens if this mass is comparable, to this mass, then as you go up, what happens to tension? Tension increases. So tension at A is minimum and tension at O is maximum. Then velocity here is maximum and velocity here is minimum, okay. Then also from here to half, it moves with lesser speed, but later it moves with more speed. Now this pulse from here to half, it moves with more speed, but later with lesser speed, okay. So time taken by this pulse from O to A will be equal to time taken by this pulse from A to O, even then, okay. But will they cross at midpoint? Let us say midpoint is B. Will they cross at midpoint? No, because for this half it is traveling faster when compared to this, okay. So they will cross below B. They will cross below B. It crosses this pulse will cross midpoint quicker when compared to this pulse. So they will meet below B, okay. But that question they did not ask, okay. TAO equal TOA is correct. But will they pass at midpoint? No, okay. They will pass below midpoint, okay. The wavelength of pulse 1 becomes longer when it reaches A. Now in that case what happens? When it comes from O to A, velocity has decreased. Here velocity is maximum, here velocity is minimum. So velocity has become minimum, it has decreased. So wavelength should become minimum. So wavelength will decrease, it won't increase. Okay. But also you can find what is the relation between initial wavelength and final wavelength, because you know relation between initial velocity and final velocity if mass of the string is given. Okay. The velocities of two pulses are same at midpoint of the rope. That is anyhow correct. Whether this rope is mass is comparable or not comparable, tension at midpoint will be same. So when they are passing through midpoint, their speeds should be same. Actually velocities are same they are asking, so we have to see because they have given velocities. Okay. Velocity of lower pulse will be upwards, velocity of upper pulse is downwards. So directions are different. So velocities are same, we cannot tell, but speeds are same. Okay. Speeds are same. So D also should not put that choice. Okay. Next question. A particle of mass m can move along x-axis of a coordinate frame in a force field of stationary sources. Potential energy U of the system varies with position x. The particle, according to equation, U equal to k into mod x, where k is a positive constant. If the particle is projected from origin with a kinetic energy E, find the period of its bound motion. Now this particle is initially at origin and projected with some velocity v naught, let us, where half m v naught square is its kinetic energy. Now towards right of this point, potential energy as a function of x they have given. Okay, what is potential energy? K into mod x. K into mod x means towards right of origin x is positive. So potential energy is kx when x is greater than 0. Okay. And towards left of origin where x is negative, potential energy is given by minus kx. K is less than 0. Okay. So what is force? Force is minus du by dx. So force is minus k when x is greater than 0, and force is plus k when x is less than 0. Means towards right of origin force is negative but constant. So force is towards left. Negative means towards left. Towards left of origin force is positive, means towards right. So it's a restoring force. Origin is mean position where force is at x equal to 0. Force is constant anyhow. Okay. K mod x. Okay. So this is from here, if I displace it towards right, force is acting towards left. Towards left, force is acting towards right, but it is a constant force acting. So it comes back, but it is not SHM because force is constant. Okay. Then what is time period of oscillation? Time taken, let us say it goes and stop at A, then it comes from A to O, then goes and stops at B, and comes from B to O. That is one oscillation. That is time period. But anyhow, because force is same in magnitude here and here, what is time taken from O to A is same as A to O or O to B or B to O. So time taken to go from O to A you find and multiply with 4, you will get time period of oscillation. What is time taken to go from O to A? You can use what is force is k towards left, initial velocity v naught. Okay. So what is time taken is v naught by k. So what is time period? 4t, that is 4 v naught by k. But they are asking in terms of E, I think. Okay, that you can find. What is v naught? Under root 2e by m. Under root 2e by m. It is under root 2e by m. V naught is under root 2e by m. So 4 by k under root 2e by m. Okay. What is the answer you will get? Why you don't get, I think. Maybe this is correct. Okay. Because if I multiply and divide it 2, you will get 8. So answer is B. But anyhow 2e by m, but that is also me is there. Oh, here I did mistake, I think. Force kada. K is force. Okay. So acceleration you have to find. The acceleration is k by m. So mv naught I'll get. So 4 times means what do you get? 4 mv naught I'll get. Okay. So 4 times this outside m I'll get. So inside root m I'll get. Okay. So nothing else is there inside, only root mv. That is the correct answer. Okay. You can do by dimensions also anyhow, because different units they have given everywhere. The next question is this: a horizontal stretched string fixed at two ends is vibrating in its fifth harmonic. According to the equation, y of xt is equal to 0.01 to sine 62.8 into cos 628t. So what is the equation for stationary waves? Is a sine kx cos omega t or sin omega t, whatever it is. It all depends on where is it initially at t equal to 0. That's what you'll get. Okay. Assuming pi equal to 3.14, the correct statement is the number of nodes are 5. Okay. It is so string fixed at both ends means what is fundamental frequency? V by 2L, and second harmonic 2V by 2L, third harmonic 3V by 3L. So nth harmonic is NV by 2L. Now if it is oscillating in nth harmonic means there will be n loops. There will be n loops. First harmonic or fundamental, there is only one loop, means 2 nodes. One loop means there are 2 nodes. And second harmonic means two loops, means 3 nodes. So in general nth harmonic means n plus 1 nodes you will get. So if it is fifth harmonic, you should get 6 nodes. So this will be wrong. Okay. Next, the length of the string is 0.25 meters. What is length of the string now? Fifth harmonic. Now if it is fundamental, then length of the string is lambda by 2. Lambda by 2. If it is second harmonic, it is 2 lambda by 2, or lambda whatever, 2 lambda by 2. So in general, if it is nth harmonic, what is length of the string? N loops. Okay. Each loop, what is length? Lambda by 2. So n loops, n lambda by 2 is length of the string. Okay. So if it is fifth harmonic, what is length of the string? Pi lambda by 2. But what is lambda? Coefficient of x in this sin kx, k, wave number, that is 2 pi by lambda. Okay. What is lambda? 2 pi by k. 2 pi by k is how much? 62.8. Okay. But pi is 3.14. Okay. So 3.14 and 62.18 means 20 times, I think. Okay. So this is 20. So 1 by 10. So lambda is 0.1 meters. Okay. Lambda is 0.1 meters. Then what is length? 5 lambda by 2. It's 2.5 into 0.1. That is 0.25. So what is length of the string? 0.25 meters. So this is correct. Next, the maximum displacement of the midpoint of the string from its equilibrium position is 0.01. That is nothing but amplitude. If it is 2 loops, even number of loops, then midpoint is node I'll get. If it is odd number of loops, then midpoint is antinode. So because it is 5 loops, then midpoint is an antinode. What is its maximum displacement? It is maximum amplitude. Antinode means. Okay. So what is maximum possible amplitude is 0.01. So that is also correct. 0.01 meters. Next, the fundamental frequency is 100 Hz. What is fundamental frequency? Is V by 2L. V by 2L. Okay. And what is velocity? Omega by k. Velocity is omega by k. And what is fundamental frequency? Is V by 2L. So omega by k into 2L. Okay. That's what it is. What is length? 0.25. Or you can write in terms of lambda also. Okay. N lambda by 2. What is L? N lambda by 2. Okay. Write it like this. L. Fundamental only they are asking. Okay. What is omega by k? You can find. What is omega? 628 and k is 62.8. So omega by k is 10. So velocity is 10. Okay. So what is fundamental frequency? 10 by 2L. 2 into 0.1. Okay. So 10 by 0.2. Okay, 10 by 0.2, 100 by 2, 50 you'll get, I think. Fundamental frequency is 50 hertz. Okay. So this is next question. We'll see. This is next question. A uniform inextensible rope of length L and a light inextensible thread are connected at their ends A and B to make a loop. Inextensible rope of length L and a light inextensible thread are connected at their ends A and B to make a loop. The thread passes over a fixed ideal pulley and the rope passes under another fixed ideal pulley. Okay. The junction B is pulled slightly downwards and then released. And find period of ensuing oscillations. Acceleration of free fall is G. Okay. Now initially both these levels are at, both A and B are at same level, then this is in equilibrium. The gravitational force acting here and here is same. Let us say mass per unit length is lambda, and what is total length of the rope they have given? L. So this is L by 2 and this is also L by 2. Then here gravitational force is same, so tension here and here is same. So it is in equilibrium. Now if I slightly pull B by x, let us say, then here A goes up by x. So what is net restoring force? Is increase in gravitational force in this region minus decrease in gravitational force in this region. If it comes down by x, what is decrease in gravitational force here? Lambda gx. What is increase in gravitational force here? Lambda gx. So what is restoring force? Is 2 lambda gx. So restoring force is proportional to x, we have shown. So it executes SHM. Then what is angular frequency of oscillation? Root of coefficient of x by m, that is 2 lambda g by mass is L lambda. So that's what it is. Under root 2g by L. So what is time period? 2 pi root L by 2g. 2 pi root L by 2g, that is A L. Okay. Now next this question. Two men are walking along a horizontal straight line in the same direction. The man in front walks at a speed of 1 meter per second and the man behind walks at a speed of 2 meters per second. So one person is, the man in front is walking with 1 meter per second and the man behind is walking with 2 meters per second. Okay. The third man is standing at a height of 12 meters above the same horizontal line such that all the 3 men are in a vertical plane. The 2 walking men are blowing identical whistles which emit a sound of frequency 1430 Hz. The speed of sound in air is 330 at the instant when the moving men are 10 meters apart. The stationary man is equidistant from them. So he should be above midpoint. Okay. Means this is 12 meters and this will be 5 meters. So this is also 5 meters. This is stationary man. Then the frequency of beats in heads heard by the stationary man at this instant. Now he is sounding a frequency f, he is also sounding a frequency f. Okay. Then this is a stationary observer and these are the two sources. One source has a velocity component towards the observer, one force away. Okay. Then what is apparent frequency? Apparent frequency is given by velocity of sound by v. These are sources. Okay. So you will get in denominator. In one case v minus vs cos theta I will get. Another case v plus vs cos theta. In this case it is towards. Source velocity component is towards the observer. So v minus vs cos theta. In the second case it is v plus vs cos theta. Okay. But source velocity is very small when compared to sound velocity. So we can write this using binomial expansion. If I take v common, then I will get 1 minus vs by v whole to the power of minus 1, which can be written as 1 plus vs cos theta by v into f. Okay. Similarly, what is f2? denominator will get plus because it is going away, and same theta because same similar triangles. Okay, then what do you get? In between minus L. F2 is equal to 1 minus Vs cos theta by V into F. Okay, then what is beat frequency? Is difference. What is beat frequency? Difference of those two is 2 Vs cos theta by V into F will get. That's all. Okay, this is beat frequency. That's what he's asking, I think. So how much you'll get? 2 into what is Vs? Oh, but Vs is different. Okay, we'll see. First one is 1 meter per second. Oh, this is 1 and this is 2. So here, okay, doesn't matter. This is Vs, I'll assume. This is Vs. So Vs is 1. Then this will be 2 Vs. This will be 2 Vs. So here 2 I'll get. Then if I subtract those two, you'll get 3 Vs. Okay. So here 3. If I assume Vs is 1. Okay. So what do you get now? I thought both of them are equal velocities. Okay, doesn't matter. 3 into Vs. What is Vs? 1 I have taken. And cos theta. Cos theta I can find. This is theta. Okay. Tan theta is 12 by 5. So cos theta is 5 by 13 I'll get. So 5 by 13 into V is velocity of sound, that is 330. And this is 1430. Okay. 1430 means I think it cancels 11 times. And this is 30. And this is 6 anyhow. So 5. So 0.2 will get, I think. Okay, calculations you can see. 0.2 heads. Okay, that is beat frequency. 1 by 5. I think you have followed. Now this is the question next. When the arrangement shown is in equilibrium, the spring on the right is stretched by an amount x naught. Coefficient of static friction between the blocks is mu, and the horizontal floor is frictionless. Both the blocks have equal mass m, and force constants of the springs are 3k and k as shown in the figure. Find the maximum amplitude of oscillations of the block along the springs that does not allow them to slide on each other. Acceleration of free fall is g. Okay, so if it is in equilibrium initially, if it is natural length, then if I displace it by x naught, okay, then this will be compressed by x naught and this will be elongated by x naught. Then x naught will become amplitude of oscillation. X naught will become amplitude of oscillation. Okay. Spring on the right is stretched by x naught, means this is compressed by x naught, whatever it is. Okay. Then what is maximum acceleration if they are oscillating with an amplitude of x naught? What is maximum acceleration possible if they are oscillating together? These two springs, effective spring constant is 4k I'll get. Then what is angular frequency of oscillation? Is root 4k by 2m. So root 2k by m I'll get. Root 2k by m. Okay. And coefficient of friction between the two blocks is mu. So what is maximum acceleration? Is A, let us say. That is omega square into amplitude of oscillation. That is 2k by m into x naught. So this is maximum acceleration for both the blocks. Let us say if they are towards right of mean position, they are somewhere here, where this is x naught. Okay. Then acceleration will be in this direction. Okay. Now if only upper block if I consider, on that spring force towards left is more when compared to the lower block. Okay. On lower block, what is spring force towards left is only kx naught. On upper block it is 3kx naught. Okay. So if they have to oscillate together, the frictional force between these two blocks should provide the extra acceleration for lower block. So frictional force between these two blocks will act towards left on lower block and towards right on upper block. And what is minimum coefficient of friction if they ask, so that they oscillate? Okay, they are asking maximum amplitude and coefficient of friction is mu. So at extreme position, if they ask maximum amplitude, the maximum possible friction is acting will take. What is maximum possible friction here is mu mg, and on lower block it will act towards left in the direction of acceleration, and the upper block it will act towards right. Okay. So what is the equation for lower block? You'll get kx naught towards left plus mu mg towards left is equal to maximum acceleration, mass into acceleration, that is 2 kx naught. Okay. What is x naught? Mu mg by 2k, mu mg by k. Okay, that's what it is. So that can be maximum amplitude. If it is towards right, if it is towards left also same, on this maximum force is towards right. Okay. So spring is applying more force on this upper block when compared to that spring applies on lower block. So frictional force should accelerate lower block, and it will be a retarding force for upper block. Next question. Okay. So these are the questions. Then other questions we can see later. Okay. So next topic we'll see. Thank you.